Hey guys, welcome to chemistry. For the 20 years that I've taught anatomy physiology courses, students always ask why teach chemistry in an anatomy and physiology course. Well, basically, any anatomical structure that we're going to look at and any physiological activity that we're going to consider throughout this course is going to have to take into consideration the chemicals and the type of chemical bonds that are associated with those chemicals that are occurring in these interactions. So for that reason, we have to have a basic knowledge of chemistry and the components that make up our human body. Now, when we take a look at the chemistry behind the human body, there's two terms that we take into consideration. One of those terms is going to be matter, and the other one of those terms is going to be energy. Because as we take a look at the matter that makes up the human body and the energy, the ways in which we put that matter to work, we're going to see that chemistry is actually going to be the wizard behind the physiological curtain that is our human body. Now let's take a look at this matter. What is matter? Matter is anything that occupies space and has a mass. Now sit back just a moment and take that into consideration. Is your body composed of matter? Is air considered to be matter? All these things occupy space, and in reality all of them do have a mass to them. Now what is a mass? Mass is going to be comparable to weight, except mass is going to be consistent regardless of where at that given moment we're going to be located at. For instance, if I'm found on Earth, I have a certain mass that will be identical to the mass that I would have on the moon. My weight would differ though, because mass does not take into consideration any kind of external forces pushing against my body as weight does. And when we're talking about matter, there's actually 4 states of matter. 3 of those states we will find played out in the human body. One of those is going to be solid, one will be a liquid, and one will be a gaseous state. All 3 of these states we will need to take into consideration when we're considering the matter that interacts and makes up the human body. Other form that we can talk about though when we're talking about chemistry will be the energy. We will spend most of this brief time here at the end of this video discussing the different forms of energy. Energy is not going to occupy space. It will not have a mass. But energy is very important because it puts matter to work. It will be what we will consider in 2 forms of energy. One of those is potential energy, and the other form is going to be kinetic energy. Potential energy is the potential stored away in things such as chemical bonds, or if you want to think of it as a rock that sits on top of a hill. Now there's a lot of potential to do damage or do work in molecules that have potential energy, but only when we initiate the process will we find converting that potential energy into kinetic energy. So notice from that description that I said, potential and kinetic are interchangeable. And there are several types of energy then. The types of energy that we're going to spend most of our time here talking about are going to be chemical energy. Chemical energy will be the energy stored in the chemical bonds. We will find a lot of times that we will take a molecule called glucose, and we will break down glucose in the presence of oxygen to generate the vast majority of the usable energy in our body. There's mechanical energy. Mechanical energy is going to be the energy to put things into motion. This typically comes from muscle contraction. There's electrical energy. Electrical energy is going to be the energy that we will use to send electrical currents down specific cell membranes. Those cell membranes we'll find associated with the muscle, and we'll find associated with the nervous system. There's electromagnetic energy. Now, electromagnetic energy we usually think of in waves. Wave energy, energy that we generate from emitting waves, as in X-rays, or that we will emit. Sound is going to be something that we pick up in waves, as will be vision. Now, something unique about each one of these types of energy is these types of energies are convertible from potential back to kinetic, and they're also interchangeable because I can take the energy that's stored in chemical bonds and use that energy to drive the mechanical energy, for instance. But this interchangeability is not a 100% efficient mechanism. Each time that we convert from one energy form or one energy type to another, we will find that we will have a small bit to a significant amount of the potential energy not being actually converted over into that new form. Instead, it will be released as heat. Heat is a type of energy that we will take into consideration quite regularly. Heat energy is going to be non-reusable because once we convert a type of energy into heat, it is non-reusable, but it is very important to us because it does allow us to be warm-blooded organisms. It allows us to stand out and watch a football game, for instance, in the middle of the fall weather in the evening and shiver and generate the heat that we need to drive the reactions that are found in our body. Now it's time for you to step back just a moment, take into consideration the differences between matter and energy, and take into consideration the types and forms of energy and how heat is different but unique and very valuable to us. Have a good day.